Hi everyone, and welcome to another episode of Chemistry with Wikipedia. Today I will be doing a tutorial on significant figures. We'll talk about what they are, how to count them, and where to use them. Okay, first off, if we are measuring something, we need to measure it to the correct number of significant figures, and then that measurement is what we use in calculations. All right, so for significant figures, we count to the digit that we know, and then we estimate the next digit. So here, if I look at this is approximately halfway between 61 and 62. So I know that it's at least 61. And so I'm going to estimate between 61 and 62. I'm just going to say 61.5 because that's about halfway to me. If you put 61.4, 61.7, that's okay. The whole thing is that the last digit is an estimated digit. So anytime we look at a measurement, we know that the very last digit of that measurement is a digit that was estimated by whoever took the measurement. All right. So whenever we deal with measurements that have significant figures, we have to figure out which digits are significant and which are not. So our rules here are anything that's non-zero is always significant. So 1, 2, 3, 4, 5, 6, 7, 8, 9, all significant digits. Zeros are the tricky part. Zeros before non-zeros are never significant. So if we have 0.005, that is one significant figure because zeros in the front are never significant. Zeros in the middle are always significant. So if I have 505, those are three significant figures. The 5 is significant, the 0, and the 5 as well. 0 at the end of a number is only significant if there is a decimal place. If there's no decimal place, then they are not significant. And if there is a decimal place, then they are significant. So 50.0 is three significant figures, but 50 with no decimal place is only one significant figure. So the decimal makes both of these trailing zeros significant. The lack of decimal here makes this zero insignificant. And then lastly, any counted number, constant, or conversion factor has an infinite number of significant figures because those are exact values, and basically we do not count them towards the total number of significant figures in our problem. Do some examples here. We're going to identify the number of significant figures in each measurement and then express that value in three significant figures. All right, so let's look at the first one. Each of these digits is not zero. That means that they're all significant regardless of whether or not there's a decimal place. So 1, 2, 3, 4, 5 significant figures here. So now I want to round this to three significant figures. So I start at the left-hand side with the first non-zero, 1, 2, 3. So that's my cutoff. And then this 7 means that the 6 rounds up. So this is going to be 257. However, my value here is 2000, so my value here also needs to be 2000. If the decimal place gets cut off when you are doing your significant figures, you have to add placeholder zeros to take you to the decimal. We do not put a decimal place there because that makes the zero significant. Let's look at the next one. Here we have 3 zeros at the end. Because there's a decimal place here, all of these zeros are significant. So 1, 2, 3, 4, 5, 6. 6 significant figures. And then if I want to round this to 3, 1, 2, 3, my cutoff is 385. It's right at my decimal. So I can leave it as 385. I can put a decimal there. Because there are no zeros, putting a decimal does not make any difference. Next up, we have zeros in the front. These are lead. So none of these are significant. So my significant figure starts here with this 4. So I have 1, 2, 3, 4, 5 sig figs. And then when I'm putting this into three significant figures, I have to put these placeholder zeros here, but they don't count towards the total sig figs in my problem. So I don't start counting sig figs until I get to this 4. So I have 1, 2, 3. This is my cutoff here. This 5 behind the 2 means that the 2 rounds up. And this becomes 4, 7, 3. And then I have forgotten my first rule, which is that you must have units. Liters and meters. All right. Let's shift to the other side here. Here I have a 0 in the middle. 0 in the middles are always significant. So this would be 1, 2, 3, 4, 5, 6. 6 sig figs. And then if I round to 3, 1, 2, 3. So my cutoff here is 847, but there is an understood decimal place behind that 6 there, so I need 3 placeholder zeros to keep the value of my answer. So if you're not sure whether you need placeholder zeros or not, you can kind of think to yourself, all right, so this value is 800,000, so my answer also needs to be somewhere in the 800,000s. Without the zeros, it's just 847, which is not the same as 8,047. 800,047. 847,000. There it is. All right. Look at the next one. This 0 is at the end, but there's no decimal, so it is not significant. So I only have 1, 2, 3 significant figures here. All right. And then if I'm putting it in 3 significant figures, I've already got 3 sig figs, so I don't have to do anything to this value. And then let's look at the last one here. I have zeros in the beginning and zeros at the end. So the zeros at the beginning are never significant, but the zeros at the end are significant because I have a decimal place. So I go 1, 2, 3, 4 significant figures here. And then I'm going to reduce this down to 3 sig figs. So again, the zeros in the beginning, even though they are not significant, they're still placeholders. So I'm going to leave those there. Then I start counting my sig figs with the 8. So I go 1, 2, 3. So basically, I'm just going to drop that last 0, and that will give me 3 significant figures. So this is how we find the number of significant figures and then how we round to the correct number of sig figs. All right, so when is this useful? When we are doing calculations. So we have 2 different types of calculations we can do. We can either multiply or divide, or we can add and subtract. Multiplication and division are grouped together because they have the same set of rules. Addition and subtraction are grouped together because they also have the same set of rules. All right, so multiplying and dividing, we count the number of sig figs in each of my measurements, and then my answer will have the same sig figs as the measurement with the least sig figs. All right, so I just count sig figs and then I use the smallest number. So if we look at these 2 examples here, I'm just going to do this math, 8.19 times 2.8. So when we put that into the calculator, we get 22.932 centimeters. So if I want to put this into the correct number of significant figures, I need to know the sig figs in each of my values. All right, so I have 1, 2, 3 sig figs in this first value, and 1, 2 sig figs in the second value. So 2 is smaller than 3, so my answer will have 2 significant figures. So 1, 2, there's my cutoff. The 9 means that I round up. So my answer here is going to be 23 centimeters. Because there's no 0 in my value, it doesn't matter whether I put the decimal there or not. All right, let's look at this next one. This is a division problem. So I divide this, put it into my calculator, and I get 2.056939 liters. So to put this in the correct number of significant figures, I count each of my values here. So I have 1, 2, 3, 4, 5 sig figs in the top value. The bottom value has zeros because there's no decimal place. Not all the zeros are not significant. So I only have 2 sig figs. So 2 is smaller than 5. So my answer will have 2 significant figures. So 1, 2. So I have 2.0. This 5 behind the O means that I round up, and this becomes 2.1 liters. Right? So for multiplication and division, I can count all the sig figs for each measurement and then use the smallest number to get my answer. For addition and subtraction, we're still looking at the smallest, but instead of counting all of the significant figures, we are only going to count the digits that are behind the decimal. So we're only going to count whatever is to the right-hand side of the decimal, regardless of whether there's a 0 there or not. Once we count everything behind the decimal, our answer will have as many decimal places as the measurement with the least number of decimal places. So it's always about picking the smaller number. We're not adding sig figs together, we're not subtracting them, multiplying, dividing. We're looking at the sig figs in each measurement, or the digits behind the decimal in each measurement, and then we're just picking the smaller of the values. Okay, so if we look at this here, I have 248.1 plus 36.275. So if we put this into the calculator, we get 284.375. So since I added in this, I'm only going to look at the digits behind the decimal. So anything that's to the right of my decimal place. So here I only have 1 digit. Here I have 3 digits. All right. So 1 is smaller than 3. So my answer will have 1 digit after the decimal place. All right, so this time I don't count from the beginning of my value, I count from the decimal place. So I just go over 1, that's my cutoff. The 7 means that the 3 rounds up to a 4. So this would be 284.4 grams. If we look at another example here, here I'm adding 35.725 plus 181.912 minus 5.20. All right, so if we do all of this math, we put it into the calculator and we get 212.437. All right, so again, I'm going to count all the digits to the right of the decimal place. So 725 is 3 digits, 912 is 3 digits, and then 2 and 0 are 2 digits. Here, it doesn't matter if it's a 0 or a non-zero. Anything after the decimal place counts. So 2 is the smallest value here, so my answer will have 2 digits after the decimal. So I count at the decimal and I go 1, 2 over. The 7 means that I round up, and so I have 212.44 seconds would be my answer here. So this is how we calculate using sig figs. Been another episode of Chemistry with Capadia, tutorial edition. I hope you learned something, and until next time, keep on chemin'.